For instance, I am pushing these two boxes, the smaller box and the bigger boxes. What will be the acceleration or my acceleration? What will be my acceleration? Good day everyone! Welcome to Surfax Learning Channel. Good day, Stempo Galileo. Good day to all my viewers. Good day to all who are taking General Physics 1. For today's video, pag-uusapan po natin ang second law of motion, the law of acceleration. So alamin po natin paano nga ba ma-determine yung acceleration of a moving body using second law of motion, the law of acceleration. Kung nais mo malaman, panoorin mo ang video ito. At kung bago ka sa channel na ito, nagustuhan mo ang video ito, sana to show your support, i-click mo ang subscription button at ang notification bell para updated ka sa mga susunod kong video lessons. Happy learning, everyone!
Good day. Ang pag-uusapan niya natin ngayon ay patungkol po sa Newton's second law of motion. This is under the MELC number 24 and 27. Here are the most essential learning target for this concept, Newton's second law of motion. First is to apply Newton's second law and kinematics to obtain quantitative and qualitative conclusions about the velocity and acceleration of one or more bodies and the contact and non-contact forces acting on one or more bodies. Second, solve problems using Newton's laws of motion in contexts such as, but not limited to, ropes and pulleys, the design of mobile sculpture, transport of loads, or conveyors, both force needed to move stalled vehicles, determination of safe driving speed and bank curve roads, and then calculate the dot or scalar product of vectors and determine the work done by a force acting on a system. In Newton's second law, the acceleration produced by the force on an object is directly proportional to the magnitude of the net force and the same direction as the net force and is inversely proportional to the mass of the object, mathematically expressed as acceleration is equal to net force over mass. This verbal statement can express in equation as A is equals to F of net over M. And this equation is often rearranged as I discussed last time. We can use the basic way of expressing equations, the triangle method. And this can be an F net is equals to M times A. For instance, in a free-falling bodies with air resistance, let us have an example here. In the diagram below, free body diagram showing the forces acting upon an 85 kg skydiver are shown. For each case, you use diagrams to determine the net force and acceleration of the skydiver at each instant in time. So you have here 4 diagrams. Diagram A, you have 833 newtons force of gravity. Diagram B, you have an air resistance of 350 newtons. with the same force of gravity, and diagram C, you have 700 newtons air resistance and same force of gravity, 833. Diagram D, you have an 833 air resistance and 833 force of gravity. Remember that in free-falling bodies, the direction of the body is downward. Therefore, anything which resists that downward motion is negative. So the direction of the body downwardly is positive, while the opposing force on it will serve as the negative force. For diagram A, to solve for net force, since our direction here is downward, therefore our net force is equal to the gravitational force, which is 833.0 newtons. By substitution with the formula or mathematical expression of acceleration, acceleration is equal to net force over mass, or net force is equals to its gravitational force, 833 newtons, divided by the mass of the body, which is 85 kilograms, which is given on the problem. To divide it, or by dividing it, therefore you will have 9.8 meters per second squared. Question, why meters per second squared is the unit? Because 1 newton is equals to 1 kilogram meters per second squared. Cancelled out kilograms, therefore the remaining unit is meters per second. For diagram B, you have now here an air resistance that air resistance 350 newtons. Again, the direction of the body is downward. We take that direction as a positive direction. Therefore, any opposing forces will serve as a negative direction, as an opposing force. So therefore, to get our net force, we will subtract the force of gravity minus its air resistance. Our force of gravity here is 833.0 newtons minus the air resistance 350 newtons. Therefore, your net force is equals to 483.0 newtons. To calculate for the acceleration, you will get F net over m as the expression of acceleration is. By substitution, you have 483.0 newtons for your net force, and your mass of this body is 85.0 kilograms. Divide 483 divided by 85 will get 5.68. Again, 1 newton is equals to 1 kilogram meters per second squared, cancel kilogram, therefore you have meters per second squared unit measure. Alright, so for diagram B, C and D, it's your time now to practice. Okay?
For instance, I am pushing these two boxes, the smaller box and the bigger boxes. What will be the acceleration, or my acceleration? What will be my acceleration? Okay, for us to calculate the acceleration as I pushes the two boxes, let us have a free body diagram. Okay, so let us assume that this is the smaller box, this is the bigger one, and let us assume that the smaller box has a mass of 5 kilograms and the bigger one has a mass of 10 kilograms. So what we have to do is, let us draw a free body diagram. So we will draw here and an applied force. But this is your FAF, force applied. But I have only here 5 kilograms and 10 kilograms. So I will compute my applied force. Since I have no given applied force here, I will compute my own applied force. Sabi po ni law of gravitation, force is equals to weight. Therefore, weight is equals to acceleration, mass times acceleration due to gravity. And that is, my mass is 75. My mass is 75 kilograms times 9.8 meters per second squared, which is constant. Multiply 75 times 9.8, that is equal to 735 kilogram meters per second squared is equal to Newton. Take note, 1 kilogram is equals to 1 kilogram, that meters per second squared is equal to 1 Newton. So my force applied here is 735 newtons. Now, for us to know the acceleration, we need to apply system analysis. We will do individual system analysis of these boxes. So let's choose first box 1, which is 5 kilograms. So if this is your smaller box, which is 5 kilograms, by drawing the force diagram, so this is my applied force, F, which is 735 Newton. And then, for us to know the force of this box, the normal force and the weight force, we will apply this formula. Weight is equals to mass times acceleration due to gravity. So that is 5 kilogram times acceleration due to gravity, 9.8 meters per second squared. Okay? And that is equal to 49 newtons. 49 newtons. And then, therefore, your normal force is, your weight force is 49 newtons. And normal force is 49 newtons. So, this is your system analysis for box 1. And we have here the contact force. Contact force is going up here. Okay? For box number 2, let us have our system analysis for box number 2. Let us assume that this is our box number 2. This is 10 kilograms. And again, the contact force is going up here. This is the contact force and contact. And contact then. And this is our normal force and normal force. So your normal force for box number 2 is equal to weight is equal to m times g, which is 10 kilogram times 9.8 meters per second squared, and that is equal to 98 newtons. So your normal force here is 98 newtons, and this is 98 newtons. So now we have already our free body diagram for both boxes as our system analysis for box A, which is 5 kilograms, and box B, which is 10 kilograms. And now for sure we are ready to solve for the acceleration. What will be the acceleration? To get the acceleration, we will just use F is equals to A is equals to F by A is equals to solve for our acceleration is equals to, from the second law of motion, F net is equals to mass times acceleration. So we will just substitute our given for net force times mass times its acceleration. It so happened here in our box A, our normal force and weight force is equal, therefore it will be cancelled out, and our net force is equal to 735 newtons, which is our applied force. So this will serve as our net force. Alright? Is equal to the mass of the first box times its acceleration, copy the quantity acceleration. In box number 2, you will notice here we don't have any net force. Kasi the force of this box rely on the force pushes from box A, which is 5 kilograms. Therefore, we will just copy 10 kilograms, and this will be as well cancelled out dahil equal yung kanilang magnitude. So, ang natira na lang is 10 kilograms. And therefore, we will substitute 10 kilograms here, or we will put 10 kilograms here, plus, kasi dalawa din naman sila, diba? Dalawa sila magkasama na itutulak lang si 10 kilograms. So, 5 kilograms for this, times A, plus 10 kilograms times A. So, you will have 735 newtons is equals to 5 times 5 kilograms plus 10 kilograms is 15 kilograms times A. So for us to calculate for acceleration, let's divide both sides by 15 kilograms. 15 kilograms. Cancel out here, both 15 equal to 1. And your acceleration is remain 735 divided by 15 is equals to 49. So Newton divided by kilogram. So ganito po kasi yan. Sulat ko dito. 1 Newton is equals to kilogram that meters per second squared. So kilogram that meters per second squared over kilograms. So cancel out yung kilograms. The remaining unit is meters per second. So this is meters per second squared is your acceleration.
Now going to multiply vectors, using the dot or scalar product. So, what is a dot product? In mathematics, the dot product or scalar product is an algebraic operation that takes two equal length sequences of numbers, usually coordinate vectors, and returns a single number. The name, dot product, is derived from the centered dot. That is often used to designate this operation. The alternative name, scalar product, emphasizes that the result is a scalar, rather than a vector, as is the case for the vector product in three-dimensional space. It is written as a dot b, which means the dot product of a and b. we can calculate the dot product of two vectors this way, where A is the magnitude or length of vector A, B is the magnitude or length of vector B, and theta is the angle between A and B. So the scalar product of two vectors A and B is defined as A dot B equals AB cosine theta. Or we can calculate it this way. We multiply the x's, multiply the y's, then add. And the result is a number called a scalar, so we know it is not a vector. Now let's try this. Calculate the dot product of vectors A and B. To solve this, let us first observe our illustration. We have magnitude of vector A, which is 10 units. We also have the magnitude of vector B, which is 13 units. And the value of angle theta, which is 59.5 degrees. Remembering the formula discussed in the earlier part of this video, A dot B cosine theta, we can now calculate the dot product of the vectors. Substituting the magnitudes of A and B to our formula, we can write A dot B equals 10 times 13 times cosine 59.5. So, A dot B, or the dot product of A and B is equals to 65.98 or 66 when rounded. Furthermore, if we look at our given illustration again, we can notice that the magnitudes of the x and y components of the vectors are also given. Now using the formula for the x and y components of the vector, we substitute 6 for A sub x, 8 for A sub y, 5 for B sub x, and 13 for B sub y. Calculating this, we get the dot product of A and B equals to 66. As we can see, using either of the two formulas will give the same answer. Thus, we can choose the most convenient one for us, or whichever is suitable for the given. You may be wondering until now, why cosine theta? To multiply two vectors it makes sense to multiply their lengths together, but only when they point in the same direction. So we make one point in the same direction as the other by multiplying by cosine theta. We take the component of A that lies alongside B, like shining a light to see where the shadow lies. It works exactly the same if we projected B alongside A then multiplied, because it doesn't matter which order we do the multiplication. Some of you may be clever and think, what if the angle formed as a right angle? Because it is not impossible to encounter vectors that are perpendicular to each other. When two vectors are at right angles to each other the dot product is 0. To prove this, let's show a solution. Using the formula, AB cosine theta. Although the magnitude or length of the vectors A and B are not given, we can calculate that cosine 90 degrees is equals to 0. And any number multiplied to 0 is equals to 0. So whatever the magnitudes of vectors A and B are, the final answer for the dot product of A and B is still equal to 0. Or we can calculate it the another way using their x and y components. Substituting the values, -12 for A sub x, 12 for B sub x, 16 for A sub y, and 9 for B sub y. We get -144 plus 144, which is equals to 0. Thus, perpendicular vectors or vectors whose angle between them is equals to 90 which is a right angle, will always have a dot product equals to 0. We can also multiply, or get the dot product of vectors in 3 or more dimensions. For example, Sam has measured the end points of two poles, and wants to know the angle between them. To solve this, we only need to add the z components as shown. Now substituting the values, 4 for A sub x, 8 for A sub y, 10 for A sub z, 9 for B sub x, 2 for B sub y, and 7 for B sub z. We get 36 plus 16 plus 70, which is equals to 122. Now using the formula AB cosine theta, we need to calculate the magnitude or length of the vectors A and B. To get their magnitudes, we will be using Pythagorean theorem. Then we get the magnitude of A as the square root of 180 and the magnitude of B as the square root of 134. Substituting the values we get from our previous calculations, 122 for A dot B, and the magnitudes of A and B. We can now calculate the value of theta. We get cosine theta equals 0.7855. Rearranging, we get theta equals arc cosine 0.7855. Finally, theta is equals to 38.2 degrees. Now that we know how to calculate the scalar or dot product of vectors, let us now discuss its properties. The scalar product is commutative. A dot b is equals to b dot a. The scalar product obeys the distributive law. A dot b plus c is equals to a dot b plus a dot c. The scalar product of the unit vectors gives us I dot I equals j dot j equals k dot k equals 1. While I dot j equals I dot k equals j dot k equals 0. Lastly, the scalar product can also be written in terms of the components of a and b as a dot b equals a sub x times b sub x plus a sub y times b sub y plus a sub z times b sub z.